Hello, welcome back. In this lesson, we're going to create a class template just for accessing GPIOs. And what I mean by this is this template is going to be specifically designed for GPIOs such that we can just say get input and we will get the input. We can say set direction output and it would simply set it rather than we access the particular register. So what I'm going to do is I'm going to make a copy of our reg access. This is the project in which we created our template for setting the pin and then doing things like set pin end, set pin or get pin, etc. This one here. So I'm going to create a copy of that and then we continue from there. I'll open the project, you see what I mean, and then you can do the same. Okay, so I'm going to rename this to GPIO class template or port class template. So basically it's for accessing a port. And then I'll double click over here and then I'll open from here. So this is the project I'm talking about, the reg access. And then we had all of these. We made two types. We made another type known as dynamic, where we had just two template parameters and then we passed the address as argument to the particular functions. So you can think of this one as the static version, the other version where the arguments are passed here. We call that the dynamic version. Okay, so I'm going to add 3 more functions here and then we'll go ahead to create our port template after that is done. We're going to add a function here, reg access. I'm going to add a function here to set the pin to input, output, and then analog and then alternate. So I can come down here and let's see, reg access. I'll start off by first saying set pin input. I'll create a function. It's a static function, static void set pin output or input. We can start with output first, it's fine. And we know how to set a pin output. We need to access the mode register and then set 1 over there. We saw that already. So to do this, what I'm going to do is get the address over here. Okay, for those of us who have forgotten, let's go to the reference manual to see how to set pin output. I'll double click on reference manual over here and then page 156 is where we have the information for the page for the mode register. Okay, so this is it, page 156 over here. Okay, so if we want to set input, if we want to set output, which we are writing the function for right now, general purpose output is 10. So if we want to set PA5 to output, mode 5 is here, and then its first bit is bit 10, its second bit is bit 11. So PA5, then if we multiply 5 by 2 we get 10. We set 1 at the position of 10, and then because it's already 0 here we can leave it, or we can explicitly set bit 11 to 0 as well. Okay, so I'm going to come over here and then we say set pin output. I'm going to use the OR operation to do that. Oh, okay, we won't be able to use our OR function because inside our OR function we don't have the ability to multiply the val by 2 to get a position, just like we showed over here that we have to multiply the mode value, which is the pin number, by 2 to get its first position, such that if it's mode 5, 5 times 2 gives us 10, and then we set 1 at the position of bit 10. Okay, so let's write it from scratch rather than use the OR function. So over here we're going to do OR over here, and then we're going to say val multiply by 2, and then we're going to shift 1 to the position such that if it's pin 5 multiplied by 2 is 10, shift 1 to the position like this. Okay, and then we can cast this if we want. Right, and then once this is done, what we have next, so this would set the pin as output, as simple as that. The next one will be to set the pin as input. So I'm going to come over here and create a new function. I say static void set pin input. And let's see our reference manual. What do we have to do to set a pin as input? Over here it says input is 0 0. So if we want to set PA5 to 0 or any pin at all, remember each pin requires 2 bits to set its mode. So we have to set both of the bits to 0 0. So that's an easy one. Okay, so set pin input. I'm simply going to copy this and then paste it over here and this over here. This here I'm going to pass 0. So this here we pass 0 at the first bit of the pin. Remember 2 bits are required, and then the next bit is the bit number multiplied by 2 plus 1. Let me show you what I mean. Over here, still using PA5 or pin 5 as an example, its first bit is at position 10, that is 5 times 2. Its second bit is at position 11, which is 5 times 2 plus 1. So I'm going to copy this and then paste this over here, and then this time I'm going to say, let's see, over here actually we've been missing a bracket. Okay, we've got to close this. So we close this as well, and then we close this. Over here I'm going to say plus 1, and then we can close from here as well. Okay, so we're setting both of the bits to 0. Okay, next is set pin analog. I'm going to copy what we have over here and then set pin. If we want to set a pin to analog, let's see what it says. Set pin analog, we've got to move 1 to both bits, both positions. Okay, so I'm going to come over here, and this time we move 1 and then 1. And then the last one is set pin alternate. What if we want to set a pin to alternate function? I'll copy this and then I'll call the set pin alt. And then what does that say? For alternate function, it says the first bit, which is the bit number multiplied by 2. In our example of mode 5, which is pin 5, this will mean bit 10. That one has to be set to 0, and bit 11 has to be set to 1. So the first one, the multiply by 2 only one, should be set to 0, and then the second one to 1. Okay, so we've created the function for any mode we want. Right, we're looking good so far. So we can go ahead and create our port pin template, the template for accessing our GPIO port. I'll come down here and then I'll create a template, and then I'll zoom in a bit for you. I'll say type name. We'll take the address type, and then type name again. This will be the reg type, and then constant address type, we call this port, and then constant reg type. We call this, how about bpos for bit position. Right, so this is our template. We can keep it horizontally like this, it's fine. And I'm going to come over here, class, I'll call this port pin, open, close. Right, and then I'll put a semicolon here. Okay, and then I'm going to put access specifier here of public like this. And then we're going to write a first function. The first function is going to set the port pin direction to output. To do that, we say static void, and then we say set direction output. And what we want to do is we first have to create some we have to find a way to grab the mode register. Remember the port, we said the main register we're going to be using when we say address, it's going to normally be the output data register, right? So if we simply say take the address and then pass it to one of our functions here, you'll be passing the ODR, which is the output data register. So we have to use the output data register to get the other registers. So we can come over here and say private. So this is going to be private in here. So if we want to make our template completely decoupled from our file over here, if we want to make a standalone such that this can be given to anyone who hasn't got access to this and they'll be able to make it work, we have to define the offset in here. So I'll come over here and then I'll say constant uint 32 underscore t, and then I'll call this ODR. Let's see. Okay, let's go to our mcal-reg.h. Okay, over here we have our configuration offset. So mode register offset is 00, we know that. ODR's offset is this, IDR offset is this. Right, since we are decoupling, we said we are decoupling this from our mcal_reg.h file, we're going to make mode register the main register, since its offset is 00, such that if someone passes port to this template, the port is going to mean mode register here. So then mode register here, right? So then if we want to get ODR, we add this offset, and then IDR, we add this offset. So I'm going to copy this because we're creating an offset for ODR in here. Now, one thing we can also do is to allow the offset to be set such that when an object of the template is created, we can let the user input the offset. But I'll leave that for you to explore. Over here, we're going to set the offset values as private in this class template. So I'll say ODR offset over here. And then okay, non-constant static data member, sorry about that. Okay, so we have ODR offset. We're going to create an offset for IDR as well. IDR offset. When we come over here, the value for IDR is this. Copy this, bring it over here. Okay, so now that we have this, we can create our output port, our output register, and then our input data register, our output data register, as well as input data register. So we can say static constant, and then this is going to be register address type, and then we're going to call this PODR, meaning port output data register. This equals port. Remember, port is going to be the mode register, so this equals port plus ODR offset. And then we're going to do the same for input. Static constant ADR type PIDR equals port plus IDR offset. So this will give us the input data register. Okay, so once we've done this, we're going to create some type definitions for them. I'm going to come over here and use our reg access template that we've written over here. I'm going to come here and I'm going to say type def reg access, and then the first template parameter is going to be address type. The second is going to be reg type, just like reg access expects, and then the address is p output data, and then the reg type, which is the value, is the bit position. Right, so I'm going to call this port pin type. Right, so we're going to give the output data register port pin type because we're going to use the output data register in at least 5 functions. Right, so the output data register, although we said it's not the main register that is passed here, what is passed here is going to be the mode register, and with the mode register we're going to add the ODR offset to get the output data register. But we're creating this template called port pin type, which is the output data register PODR here. So I'm going to copy this, and then over here I'm going to change the register type over here to port, the same port here, and this means this is the mode register, and I'm going to call that port DIR type, meaning direction type, because we use the mode register to set a direction, whether input, output, alternate function, etc. Right, and then I'm going to create a final one. I'll copy this, and then I'll put this over here, and this time we're going to say we're going to pass the input data register address here, and then we're going to call this port imp type for input, like this. Okay, so we are type def in all of this so that we can simply call it this. All of this, whenever we want to type all of this, we simply use this word. Okay, so now that that is done, we can, all of this is private. All of this is private. Now that that is done, we can come to our public part of the class to continue. So over here I said set direction output. Then I can simply come and say port DIR, the DIR type that we created, port DIR type, scope resolution, and then I'll say set pin output. Remember, we have port DIR type, and this is just type reg access. And remember, in reg access we have a function called set pin output. That is why we can say port DIR type set pin output. Okay, how about set pin direction input? I can simply copy and paste this, and in here I'll say set direction input, like this. Port DIR type set pin input, like this. Okay, what's the next one? So how about set pin high? We simply want to set the pin high. Set pin high. I'll paste this. To set a pin high, we need the port port pin, which is the output data register. So I'll copy this port pin type, and then I'll rename this function. We said we're going to call it set pin high. So we have this over here, port pin type, and then we can simply call the bit set function. Right, so how about set pin low? This, we can all do it. Paste this over here. And then over here, we simply call the bit clear function. And then once that is done, how about we can have a function that would read the input value. So I'll come over here, I'll say static. This will return the input, so I'll say static bool over here, read input value, like this. And then what we want to do is return, and then this time we want port imp type for the input data register, and we can call our bit get function. Okay, finally, what if we want to toggle the pin? We can say static void toggle, then we say port pin underscore type bit not. That's the function for toggling. Right, so we have this class template called port pin, and this allows us to do whatever we want to the GPIO port. Okay, we can go ahead and test it out. So I'm going to come to our main function here. Our main function in here, let's see what we have. We have this. I'm going to take the address for our AHP1 enable register and rename it simply to AHP1. I'll say constant uint 32 underscore t over here, and AHP1 ENR, this equals this. And over here we have to add this here, and I'm going to do the same thing for our GPIO B. Let's see, do we have a GPIO B? We can change this to GPIO A, so that I'll come over here and then I'll give it a name GPIO A equals this, and then constant std uint 32 underscore t, and then I'll press a semicolon here, and over here GPIO A, and then we are good. Okay, so we have access to GPIO A and then access to our AHP1 enable register. We use this to set the clock access to the particular port, and then we use this to access the port output data register. Okay, so I'm going to clean what we have over here, and in here I'll clean it as well. So first, let's enable clock access to our GPIO A port. I'm going to use a different method here. I'll say type def over here, and then I'll call our reg access template, and then std uint 32 underscore t, and then I want to pass this over here. I want to pass AHP1 register, and then for bit position I want to pass 0 here because we want to get access to the bit corresponding to GPIO port A. And all of this, it's a type def. I'm going to give it a name. I'm going to call this AHB1 ENR B0 underscore type, like this, such that I can come here and call this AHB1 ENR B0 type. I can call bit set on it by simply saying bit set, and it would set the bit like this. Okay, so once this is done, I'm going to create a type def for GPIO port A pin 5. I'll come over here and say type def, and then this time I'm not going to use reg access. I'm going to use our port pin template. I'll say port pin, and then the first parameter is of type std uint 32 underscore t. The second parameter std uint 32 underscore t, and then the address GPIO A, the position 5, bit number 5. I'm going to give this a name PA5 type, like this. And then I'm going to come over here and say PA5 type set direction as output. This will set it as an output pin. Right, so then our pin will be configured as output just by doing this. Okay, so once that is done, do we have a toggle? Yeah, we have a toggle function. I'm going to come over here and say PA5 type, and then I'll call the toggle function toggle, like this. And then I'll put a bit of pseudo delay here by saying for int I equals 0, I is less than, let's say, a number such as 1800000, something like this, and then I plus plus. Okay, right, let's test it out. Click over here to build. It's built successfully. Click here to download onto the board. It's downloaded. Let's see if we have PA5 toggling. We are at GPIO B, so I'm going to come over here, peripheral system view, come to GPIO, and then select A over here, and then I'm going to expand ODR, and then I'm going to click here to run. Okay, PA5 is not toggling. We just have ODR 10 set. That is set by default. Let's see what's wrong with the code. Okay, so the issue is from here. Over here we said GPIO A equals ODR register, but we said in our port pin template the register we pass is going to be the mode register. We said over here this port means mode, so it doesn't have to be ODR here, it has to be simply GPIO. So I'm going to come over here, and remember GPIO is the same as mode register. So I'm going to say GPIO A is the same as GPIO A mode register, because mode register's offset from the base address is 00. So meaning the base address is the same as the address of the mode register. And we have access to this by simply saying GPIO A, because we created this together. When you come over here, GPIO A equals AHB1 peripheral base plus this, and then mode offset is 00. So GPIO A mode register is GPIO A plus GPIO A mode offset. Okay, we come over here, Ctrl S to save, click over here to build, click here to download onto the board. Okay, we can go and see, and then let's click here to run. So we have pin 5 PA5 toggling, right? And if, yeah, my LED is toggling on the Nucleo board here, but like I said, this is the ultimate confirmation. You check your debug view and find a particular pin. If it's toggling, then your firmware is working exactly as expected. So this is it. I hope you found this useful. I hope you can add this to your embedded development toolbox and apply it. If you have any questions, leave them in the questions and answers area. If you're finding the course useful or you have any feedback, kindly take some time off to leave a review, and I'll see you in the next lesson. Have a nice day.